some more problem on this weight density, mass density, specific gravity. So here a body of dimension 1.5 by 1 meter by 2 meter, which is weighing 1962 Newton in water. Find its weight in air. What will be the specific gravity? Volume of the body is given here. So that is all the three dimensions are given, multiplied together to get the volume of the body. So here weight of the body in water, so that is also given here. So then volume of the water displaced is equal to volume of the body. So then weight of the water displaced, so that is equal to weight density into volume, because weight density is equal to weight by volume. So weight is calculated taking the product of weight density into volume. So weight density is now rho into g. So that is 1000 into 9.81 into volume. So that is 3. So I am getting here weight of water displaced. So then for the equilibrium of the body, we will consider that weight of the body in air minus weight of water displaced is equal to weight in water. So that we are getting as weight of the body in air, that is not known. Weight of the water displaced just now calculated. Weight in water, so that is also given 1962. So that is it is nothing but my weight of the body in the air is calculated by taking this difference. So we are getting 31,392 Newton. So weight of the body in air is 31,392, and weight of the body in water is 1962 Newtons. So naturally we have the difference. So weight of the body in the air is more than the weight of the body inside the water. So now mass of the body is nothing but weight divided by g. So we know that W is equal to m into g. So weight in air calculated, g is 9.81. So converted to kg. So it is 3200 kg. So density of the body is mass by volume. So that is we are getting density. Once you get density, specific gravity is the ratio of density of the given substance. I mean specific uh, gravity of the body to be calculated is taken as the density of the given substance to density of the standard liquid, that is water. It is 1000 here. So it is 1066.67 by 1000. So we are getting 1.067. So that is the specific gravity of the given body. So whatever is the nature of the problem given here, so the weight, so here the Archimedes principle will be used now. So that is when a body is submerged inside the liquid, some amount of water is spilled out of the container. So the weight of the liquid which is spilling out of the container is equal to the weight of the body inside the water. So that is the principle here we are using, and then we are taking the help of the basic properties of the fluid, that is mass density, that is the ratio of mass by volume. Weight density is equal to weight by volume, and specific gravity is nothing but the density of the given substance to density of the standard liquid, so that is water. Its density is 1000. Now metacenter. What is metacenter? It is the point about which a body starts oscillating when the body is tilted by a small angle. That is before we apply a small tilt here, the position of the body is this. After I am giving a small tilt here, just I am applying a rotation here, a small rotation here, the body gets tilted to the new position now. So what is the definition now? It is the point about which the body starts oscillating when the body is tilted by a small angle. The metacenter is also defined as the point at which the line of action of the buoyancy force will meet the normal axis of the body when the body is given a small angular displacement. So, this is the axis of the normal axis of the body, and this is the line of action of the buoyancy force. So, the axis of the body and the line of action of the buoyancy force, these two lines meet at some imaginary point. That point will be called as the meta center. Now consider a body floating in a liquid as shown in the figure. Let the body is in equilibrium and G is the center of gravity and B is the center of buoyancy. For equilibrium, both the points lie on the normal axis, which is vertical. Now let the body is given a small angular displacement in clockwise direction as shown in the figure. So a small tilt is given here. So the center of buoyancy, which is the center of gravity of the displaced liquid, or center of gravity of the portion of the body which is submerged inside the liquid, will now be shifted towards the right from the normal axis. Earlier, the center of buoyancy B is on the normal axis. Now it is shifted to the new position. So that is B dash as shown in the figure. So the line of action of the buoyancy force in this new position will intersect the normal axis of the body. So this is the normal axis of the body and this is the line of action of the buoyancy force. Both will meet at some common point. So that is metacenter. Then metacentric height. The distance mg, that is the distance between the metacenter m and g, that is the center of gravity of the body. So the distance between these two points will be called as the metacentric height.